Alright, we want to take a look at a few things. Looking at graphs and how things, if we put in numbers, let's just talk about our typical y equals, let's do sine of x, okay, or sine of theta. Well, if we deal with this graph, we know if we look at our little unit circle here, again, as I said in the other videos, we concentrate on here. We've come over 1 up none. Here at 90 degrees, or pi over 2, we've gone over none up 1. Here we've gone over negative 1 up none. Here we've gone over none and down negative 1. Remember, the first value is your cosine value. So if I were doing cosine, here at 0 degrees, I would plot 1. But I'm not. I'm going to do the sine, as we said, which is our second value here, 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 and here. So at 0 we plot 0. Sine always crosses. That's an indication that it's a sine graph. At 90 degrees, or pi over 5, we're at 1. At pi, or 180, we're at back here at 0. Then it goes to negative 1, and then it goes here. It has its nice little curve. But what happens right here? What happens if instead of y of sine of 2, 0, if I do y is 2 times the sine of theta? What's going to happen then? Well, if you look at it, if we come in here and we look at 0 degrees, if we made a little t-chart, and let's say our theta here is, let's look at 0 degrees, maybe 90, 180, 270. Okay. Now, we know the typical sine of theta at 0 is 0. At 90, it's 1. At 180, it is 0 again, and then 270, it's negative 1. Well, what if I do 2 times the sine of theta? 2 times that sine value. Well, what's 2 times 0? 0. 2 times that 1? 2. 2 times that sine of theta, well, here at 180, when it's 0, 2 times 0 will give us what? 0 again. 2 times the sine of theta value, well, at negative 1, 2 times negative 1 is negative 2. So if we put the number out front, what we call the a value, you notice 0, you're still here at 0. Okay, we're graphing these right here. We're graphing 2 times the sine of theta is what we're trying to graph. At 90 degrees, or pi over 2, where it was at 1, it now goes up to 2. So instead of being here at 1, it goes up. Here at 180 degrees, or pi radians, it comes back to 0. And when it's at 270, or 1.5 pi, 3 pi over 2, we're at negative 2. And then it's back again at 0. So what happens is it stretches that guy up. Okay? It's called the amplitude. It's called the amplitude. So if I were to do y equals, let's say, 4 times the sine of theta, what do you think would happen? Well, if it's a sine graph, it's going through 0. Normally we're here at 1, but if we multiply by 4, he's going to be up where? At 4. Back here at 0 times 4 is still 0. Here where we're typically at 1, if we multiply by 4, we're now down at, at negative 1, we're now down at negative 4. And back, it'll go up and down and do that number. So the number out in front simply stretches things vertically. Okay? And that's called our amplitude. That's what happens there. Now, what if we take a look at a few other things? What else can happen? Well, notice this right here is your y equals, I made it 1. This is just simply y equals the sine of theta. But here, it still's going the same height, but notice this is what we call basically one cycle from 0 to 2 pi. It went and then it would start repeating itself every 360 degrees, or 0 to 2 pi. It repeats itself. Here, it's like an accordion. We pushed it in. What happened? Well, what happened is this is y equals, now since it goes through 0, I know it's a sine, not a cosine. And then what I did is I put this right here, 2 theta. I multiplied by 2. And when I did that, what I did is notice it creates from 0 to 360. Here it was just 1 cycle. Here it went up, down, boom. It repeated the cycle how many times? 2 times. Right there, that's going to be what we call our B value right there. And that's going to tell you that from 0 to 360, the cycle repeats twice. Because notice it goes up, down, boom. There, it completed the cycle 1 time. Up, down, boom, 2 times. Well, let's look here. Let's see how many times the cycle repeated itself. It went up, down, there. 1 cycle. Up, down, there. 2 cycles, up, down, 3 cycles. So we know that's y. Now since it goes through 0, it's sine. And how many cycles? 3 cycles. So it's y equals sine of 3 theta. And there we have the number inside here with theta determines how many cycles occur from 0 to 360 or 0 to 2 pi in radians. That's what it does. The number out front, remember, would make the amplitude. It would change things up vertically. So the number out front is going to do our vertical bit, and the number inside with theta is going to tell us how many cycles occur between 0 and 360. Like an accordion, it either stretches it out or stretches it in, pushes it in. There you have it.